lesson is on dividing rational expressions. We're going to do the following steps. We're going to factor the polynomials. We're going to cancel any common factors. We'll simplify, and then identify if there are any domain restrictions. So here's an example. We have a polynomial in the numerator and a polynomial in the denominator. And what we're going to do is we're going to factor these. So let's take care of this first polynomial. This is x squared minus 2x minus 3. It's a trinomial and the leading coefficient equals 1. So we can use our t-chart. So we set up what are the factors of negative 3 that sum to negative 2. So negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So in factored form, we're going to choose the negative 3 and the negative 1. So we'll say x minus 3 and then x plus 1. So in factored form, we'll put it up there in the numerator, x minus 3, x plus 1. All right, now let's head down to the denominator. The denominator also has a polynomial, and we want to factor it. It is a trinomial leading coefficient of 1. So we can use our t-chart, and we say what are the factors of c, which are 4, that sum to b, which are 5. So 4 times 5, or 4 times 1 is 4. 4 plus 1 is 5. So that works. We're going to go ahead and choose those numbers. So in factored form, it's going to be x plus 4 times x plus 1. So now over here, we have x plus 4 and x plus 1. Now we look to see if there's any common factors that we can cancel out. If you look in the numerator and the denominator, we have x plus 1 here and an x plus 1 there, so we can cancel those out. So in simplified form, our answer is x minus 3 over x plus 4. All right, now let's go and identify the domain restrictions. The domain restrictions are what type of numbers would not work for x that would make that denominator undefined. So if you think about undefined, it's a number with a 0 in the denominator. So if we look right here, if I look at the denominator and I substitute a negative 4n, negative 4 plus 4 is 0, makes that entire denominator 0, which is undefined. There's another number here. If I substitute negative 1 in for x, makes that negative 1 plus 1 makes it 0, undefined. So the domain restrictions, I'm going to call for short, domain restrictions, x cannot be negative 4 and x cannot be negative 1. As we move through our class, we'll learn more about what domain restrictions do when we graph functions. All right, let's do one more. So we're going to have to factor the numerator and denominator. So if we look at the first one, 3x plus 4, nothing to factor out, no GCF, so it's already set to go. Now let's look at the denominator. The denominator needs to be factored. It's a trinomial with a leading coefficient not 1. So we have to use the AC method. So to review the AC method, you take 3 times 4, 3 times negative 4, and you get negative 12. So that's going to be your left-hand side of your t-chart. The right-hand side of the t-chart is what sums to b, so sums to 1. So let's list out all the factors of negative 12. Well, negative 6 times 2, negative 3 times 4, positive 6 times negative 2, positive 3 times negative 4. So here's some scenarios. So let's go ahead and add them. So negative 6 plus 2 is negative 4. Negative 3 plus 4 is 1. 6 plus negative 2 is 4. 3 plus negative 4 is negative 1. We want the one that adds to 1 right here. So these are the numbers we're going to work with. So if you remember the AC method, you remove this term, and now you've split it up into 2 terms. So we have the 3x squared was the original, and the minus 4. Now, these 2 terms are replacing the x in the original trinomial. So what you've done is you've converted this from a trinomial to a quadnomial. Now we finish it by grouping. So I'm going to group the first two terms together, and then I'm going to group the last two terms together. And now we're going to take out their GCFs. So in the first group, I can take out a greatest common factor of 3x. So I'm left with x minus 1 when I divide out 3x from both of those terms. In the second parentheses, I can take out a greatest common factor of 4. So when I divide those by 4, I'm left with x minus 1. What will happen every time when you do the AC method at this step, the common factor left over is x minus 1. They will be the same every time the parentheses. So what we have, x minus 1 is the common factor. The leftovers, after we take those out, is 3x plus 4. All right, so now it's factorized. Let's go back up to the original problem and write down it in factored form. Now let's look to see if there's any common factors in the numerator and the denominator. And there is. There's a 3x plus 4 here. There's a 3x plus 4 here. So what we're left with is a 1 in the numerator and a 1 in the denominator. So our final answer is 1 over x minus 1. So there's our final answer in reduced form. Now, we do need to identify the domain restrictions. So the domain, we have to look right here at these two pieces. So I'm going to head down here and do a little bit of work. So the domain restrictions. X minus 1, we do not want it to equal 0. 3x plus 4, we do not want that to equal 0. Because if there's a 0 in the denominator, it makes it undefined. So we're going to solve these for x. So I'm going to solve by undoing. I'm going to add 1 to both sides. So there's one domain restriction. X cannot be 1. If we substitute 1 in, the denominator will be 0. So now we'll solve by undoing. Subtract 4 from both sides. Divide both sides by 3. So here are your two domain restrictions. X cannot be 1, and x cannot be negative 4/3.